Let me introduce you the speaker of this conference. Alain Deloire obtained his PhD in 1982 at the University of Montpellier and the DSc in 1998 at the University of Montpellier too. He worked 10 years as a researcher in viticulture at Moët & Chandon in Champagne. He has been working for 14 years as professor in grapevine and fruit ecophysiology at Montpellier SupAgro, and is co-author of 3 books on grapevine, physiology and terroir, and published around 230 publications, including peer-reviewed articles and industry articles. He worked as professor in viticulture at Stellenbosch University in South Africa from 2009 to 2012 and was head of the department from 2011 to 2012. From January 2013 to September 2016, Alain took on the role of the director at the National Wine and Grape Industry Centre in Charles Sturt University in Australia. Since November 2016, Alain is back as professor in viticulture at Montpellier University, l'Institut Agro in France.
Good morning. It's my pleasure to share with you along this talk some information on the effect of abiotic factors on vine functioning. I did prepare this presentation with some of my colleagues from Australia and obviously France and Slovenia. So I'm going to share with you some information on the climatic scales, the calculation of the climatic indices. We are going to speak about row orientation and obviously bunch fruit zone microclimate, the impact of training systems and shoot growth on canopy microclimates. We are going to speak about fruit development and composition, which is quite a complex topic. And then we will finish with a discussion around wine aromatic profiles. Climate is a key factor of the terroir concept. The main abiotic factors are temperature, light, wind, air humidity, and rainfall. Speaking about light, we have to differentiate light quantity and light quality. Regarding climatic scales, there are mainly 3 levels. What we call the macroclimate at the big region level, the mesoclimate or topoclimate, more at the vineyard level or group of vineyards, and the microclimate at the vine level, at the fruit zone level, and at the bunch level. To measure the climate, obviously you need weather stations. The weather stations will help you to assess the climate during a specific year or to assess climatic evolution, climatic changes. If you want to assess climatic evolution, you need 30 to 50 years of data. To measure or to assess the climate at the vine level or at the fruit zone level, you need loggers. You need loggers above the canopy, for example, to measure the mesoclimate, or you need loggers within the canopy at the fruit zone level to assess the microclimate. You have loggers for temperature, light, air humidity, wind, etc. Worldwide, you have different types of climate, as you already know. For example, you will have warm regions, temperate regions, cool regions. You will have tropical climates, etc. While studying the effect of temperature on vine functioning, and berry ripening, it's important to assess the temperature during the day, but as well the temperature during the night. Because we know now that during ripening, some genes are expressed only during the night. So as the figure is showing, you have hot, warm days and warm nights. This is a type of region. Then you have regions with warm days and temperate, cool nights. And obviously you have regions with temperate days and cool nights, like for example, Champagne in France. To assess the temperature of regions, there are climatic indices, and Huguelin indices is one of them. Those indices allow to classify the regions, the viticultural regions, from very warm, temperate, cool, and very cool. And those indices are very important for many reasons. One of them is to assess the evolution of the climate over 30, 50 years. And the other one is to choose the right variety which will be adapted to the temperature of the region. For example, Pinot Noir will do well in a cool temperate climate, while perhaps the Pinot Noir is not really adapted to warm, very warm climates or regions. And varieties as Grenache or Carignan or Tempranillo, for example, are well adapted to warm, very warm climate. Having said that, if you consider a variety like Chardonnay, which is very flexible, in the world you have Chardonnay in warm regions and you have Chardonnay in cool regions. What will happen? Those regions will just produce different styles of Chardonnay. If we go now in Griffiths, which is a wine regions of Australia in New South Wales, and if you look at the figure, we did the calculation of the evolution of the Huguelin index, and as I said, the Huguelin index is representing the sum of temperature from bud break to harvest. You see that this region is very warm, and at the x-axis we started with the sum of 3000, which means that this region is very warm. Interesting to see that the temperatures are still increasing within these regions, and you see that from 2006 to 2016, because we stopped the calculation year 2016, the blue bars represent the increase in temperature from 3000, meaning that this region is warming up. Another important climatic indices is the cold night index or the fresh night index, which allows the classification of regions from warm nights to very cool nights. The figure is showing that for the Griffiths region in Australia, in New South Wales, we saw that the daily temperatures are increasing, but the night temperatures are increasing as well. And the figure is showing the evolution of night temperature from 18 in terms of thresholds, which means that the region had already high night temperature, but even more, the night temperatures continue to increase. And this means that the choice of the varieties for the future in terms of adaptation to these warm temperatures and in terms of wine styles will be crucial. While studying the effect of abiotic factors on vine functioning, it's important to determine the thresholds of light, temperature, water in terms of vine water status on vine functioning. It means that it's important to determine when those factors are positive and when these abiotic factors start to be a problem in terms of vine functioning. This figure is showing the vine water status thresholds measured using the pre-dawn leaf water potential, and the thresholds are going from no water constraint to moderate water constraints and water stress. While moderate water constraints could be positive for vine functioning, reducing the vigor of the canopy, water stress has to be avoided at all costs, because then it will impact on the sustainability of a vineyard. These two figures are showing that the primary and the secondary shoots are nicely linked to vine water status. The left-hand side figure is showing that under moderate water constraint, the shoots are able to grow, the apex is still functioning. The right-hand side figure is showing that when a vine is stressed, then the apex is necrosed and the shoots cannot grow anymore. What about the effect of row orientation and planting density on fruit zone microclimate? Obviously, plantation density, row orientation, and the choice of the training system will matter in terms of canopy and bunch zone microclimate. I guess it's important to mention that irrespective of canopy and bunch zone microclimate, row orientation is chosen according to topography and mechanization as well. This figure is showing that the daily interception of light and the daily evolution of temperature will depend on row orientation. A few words now on what we call grapevine training systems. Grapevine is a liana which allows the creation of quite a lot of training systems. There are more than 40 of them currently in the world. The training system will define what we call the architecture of the vegetation, and to make a long story short, a training system is a tool to achieve two goals: yield and wine quality. And obviously the training system and the architecture of the vegetation will impact on canopy and bunch zone microclimate. So as examples, here you have what we call the vertical shoot positioning on the left-hand side, below the training system called smart die zone, and on the right-hand side you have a sprawling training system which is not released, and a gobelet chalassé. So speaking about training system, just want to remind you that obviously light, sunlight penetration and temperature will play major roles in terms of vine functioning, as well vine water status will play a crucial role in terms of vine functioning, berry development and composition. This figure is showing that the width of the canopy is important in terms of sunlight penetration. The width of the canopy is due to the growth of the laterals, the secondary shoots, and the growth of the secondary shoots is under the control of vine water and nitrogen status. This study from Le Bon et al., published in 2006, clearly did show that the rate of leaf appearance of the primary shoots is under the control of vine water status in relationship with soil water availability. So the rate of leaf appearance of primary shoots is affected, starts to be affected when the soil water availability is around 35%. If you remember, I told you that the width of the canopy is due to the growth of the secondary shoots. And this study from Le Bon et al. Did show that the secondary shoots, laterals, are more sensitive to vine water status than the primary shoots. So the rate of leaf emergence in and for the secondary shoots starts to be affected when soil water availability is around 55%. So let's speak now about fruit development and composition, which is a complex story. So abiotic factors and cultural practices in vineyards will affect berry growth, berry composition, and the dynamic of berry ripening. The relationships between berry composition and wine compositions are not so obvious because in between you have the wine making processes. And then the relation between wine composition and wine styles or wine typicality are not as well very obvious. So if you want to assess that abiotic factors or cultural practices did affect wine styles, it's very important to go to sensory analysis or to wine tasting. This very classical figure is showing the 3 stages of the growth of a population of berries. So just after flowering, you have what we call the green growth stage, then the lag phase, and then the ripening stage. The right-hand side figure is showing a bunch of Shiraz at veraison, and during veraison, at one moment, you have 3 or 4 types of berries within the cluster. The hard and green berries, the soft and green berries, meaning that those berries start at veraison, the pink and red berries. So it's heterogeneous. It means that at harvest, the berries will not have the same ripening level. This figure is showing that some important compounds that will affect wine composition and wine styles are accumulated either before veraison during the green growth stage or either after veraison during the ripening stage. The tannins, for example, and the organic acids are accumulated before veraison. And malic acid will decrease from veraison onwards. Other compounds, very classical compounds, are sugar or anthocyanins, will be accumulated from veraison onwards. As I said, some very important compounds are accumulated during the berry green growth stage, and by opening the canopy early after flowering at pea size, this will affect the accumulation of some compounds. As an example, I'm going to show you some results on what we call methoxypyrazines or pyrazines. This aromatic compound is responsible in the wine of aromas as green pepper or asparagus. The pyrazines are accumulated during the green growth stages, and then for whatever reason from veraison onwards the concentration of this compound is decreasing. So by opening the canopy from pea size onwards or at pea size, this will affect the accumulation of pyrazine. And this is a nice example of how, by opening the canopy, putting more light and temperature at the bunch level, you can affect berry growth and composition. Berry number per clusters and berry volume are an important part of the yield component. The volume of the fruit is mainly linked to vine water status. And for information, a fruit will lose water via transpiration, but very little water. But it's possible as well to have some water backflow during ripening from the fruit to the vine. From the onset of veraison, which is berry softening, and on a per berry basis, a fruit will accumulate sugar during 26 to 30 days from the onset of veraison, and then the sugar accumulation per berry will reach a plateau around 20 to 22 bricks. As the fruit is accumulating sugar, the fruit is accumulating water as well. So from the plateau of sugar and water accumulation, we can see that because the fruit is not loading any more sugar and water, the sugar concentration, which is expressed in bricks, is stable. So sugar concentration is just an equation between sugar per berry and the volume of the fruit. The reality of a vineyard for most variety is that from the plateau of sugar accumulation, because there is no more water accumulation, perhaps due to the interruption of the phloem functioning, then the fruit will lose water. And because the sugar per berry is stable, and because the fruit is losing water, then the bricks is increasing. This is nicely showing that, in fact, the increase in sugar concentration, again, is just an equation between sugar per berry and the evolution of the volume of the fruit. The ultimate stage of berry water loss is berry shriveling. And berry shriveling, in the context of climatic change, is really currently a huge problem for some varieties in a lot of warm wine regions. Interesting studies conducted in Australia, mainly in Adelaide University, did show that there is possible cell death in berries during ripening at the pulp level. Cell death in the pulp is exacerbated by higher temperature and drought. And then, obviously, the phenomena of cell death, which occurs after the plateau of berry sugar loading, will increase the berry water loss and will lead to more berry shriveling. Wine aromatic profiles are not only about fruit zone microclimate. Let's talk about it. So, wine style is not only about fruit zone microclimate. Wine style is as well about harvest dates. This figure is showing that from the plateau of berry sugar accumulation, you have three important ripening stages, which are called respectively fresh fruit, mature fruit, and jammy fruit, which is overripe. So harvest dates are crucial in terms of wine styles. It's time now to end this talk, and I will try to summarize some take-home messages within a few slides. This slide is summarizing many years of research on the effect of sunlight and temperature at the fruit zone level on fruit growth and composition. Obviously, it's not exhaustive, but at least it's a way to get some information on the positive effect of sunlight on the stimulation of the biosynthesis of some compounds. It's as well interesting to see that for other compounds like tannins, the sunlight has no effect. It's as well interesting to see that for other compounds, sunlight and temperature can decrease the metabolism of these compounds. So, speaking about light and temperature, depending on the compounds, those abiotic factors can stimulate or inhibit the biosynthesis, the accumulation of compounds. So the reasoning is there on a compound basis. So what do we have in the toolbox to change the fruit zone microclimate? Obviously, leaf and lateral removal, or both, are powerful tools or cultural practices to change fruit and wine composition and wine styles. So when to remove leaves, when to open the canopy, most of the studies did show that to have an efficient effect of sunlight within the canopy, the best stages is to open the canopy at pea size, so before veraison. Now, obviously, if you open the canopy before or after veraison, you will not have the same effect on fruit growth, fruit composition, and fruit health in terms of botrytis, for example. So, when to open the canopy during berry development will depend on your goals. Another interesting information is that from the same vineyard, for the same variety, you can get different style of wines just by opening the canopy. So, by putting more light at the fruit zone level, you can definitely change the style of wine you want to produce. For example, by opening the canopy pre-veraison at pea size, you can decrease the level of pyrazine of some varieties as Cabernet Sauvignon, Merlot, or Sauvignon Blanc, and in parallel you will boost the fruit, meaning that you will change the wine aromatic profiles. It's a great pleasure for me to introduce to you my colleagues who did help me to prepare this talk. So let's start with Susie from Australia, Anne from Montpellier SupAgro, Guillaume from Slovenia, from UNG, and Katia from the Agricultural Institute of Slovenia. So, thank you very much for your attention, and on the slide you will have the link with the SupAgro website, and I share with you my professional website link. Keep well.